My name is Muhammad Sulaiman Jasim. Today I will do the video presentation simulation part for question 1. For question 1A1 Roman, this question, first we need to write this equation in our MATLAB like this, and our upper limit and lower limit. After we don't forget to put the integral 3. This we put 3 because we want to integral 3 times. After that we just enter and we get the answer. This is the answer, and we check in our manual calculation, we get same answer. Okay, for question A to Roman, first we need to write this equation in MATLAB. After that, this is the upper limit and lower limit for y and x. This we already I already write the equation and upper limit and lower limit. Just press enter. The answer is 35.3333. In our manual calculation, we get this answer same. For the question 1B, we just write this in our MATLAB also, and our limit and upper limit for dx, this, for dy, this, and for dz, this. I do this because it make my calculation easier, because if I write this equation in integral 3 this, it probability I can do some mistake, and it difficult to check which part I do the mistake. This is the answer. We check in our manual calculation. This is we get same. So, for C1 Roman, this is the question, and question give region in between circle this and this question. We just write it in our MATLAB. This is what we get. This is the answer for this question. We check in our this is what we get. For the last part in question 1, which is question C2 Roman, this is our upper limit and lower limit. This, just go to MATLAB. This is what we will get, and we already write the upper limit and lower limit. Enter, and this is the answer. We check in our manual calculation, we get the same answer.
Assalamualaikum dan salam sejahtera. My name is Muhammad Syamil bin Abdul Adi Akimi. My matrix number is BE2030335, and I'm from section 2 group number 5, and I'm going to do question 2. Find the first partial derivative of fxyz equal to x square y over z cube and exponent power of yz cos sy. For the manual, if you want to find the fx, we just differentiate this equation with respect to x. If you want to find the fy, we just differentiate this equation with the respect to y. And if you want to find the fz, we differentiate this equation with the respect to z. Number 1, number 2 is just the same, but number 2 we are going to use product rule. Okay, I'm going to show you the simulation on MATLAB. Okay, first we must define the function xyz and we put equation here, and then we use this code to differentiate this equation with respect to x, y, and z. And I got the same answer here. This is for fz, this is for fy, and this is for fx. Okay, number two is just the same, but this should be a power off. But if I put it, it will be an arrow. Okay, so I got the same answer here, but this should be power off. But if I put it, it will be arrow. This is for fz, this is for fy, and this is for fx. For question 2b, solve delta z over delta u and delta z over delta v by the plane chain rule. This is given x, y, and z. Okay, for the manual, we just put the formula here and we solve the equation. And I already count here. For the dz over dx, I already count here, and I just replace here and I just count like usual. And for the simulation, yeah, like usual, we define the function, we put the equation, and we differentiate this equation, and I got the same answer here. Next, number 2c, show that the function z equal to exponent power of x sin y plus exponent power of y cos x satisfies Laplace equation second derivative of x plus second derivative of y equal to 0. Okay, for the manual, first, like usual, we differentiate this equation with x, and then we differentiate again this answer again with x respect to x, and then we differentiate this equation with y, and then we differentiate this equation with y, and we just arrange the equation and we got 0. For the software, yeah, like usual, we define the function xyz and we put equation here, and then differentiate this for y double s because this is for second differentiate, and double y because second differentiate, and Laplace to satisfy the Laplace equation. And if I run this, I got the same answer here, 0. This is the answer, 0. Last one, 2D, for the following equation, find delta z over delta x if z equal to fxy is explicitly defined as a function of x and y. Okay, number one and number two. Okay, for this equation, we just arrange this equation from right hand side to the left hand side, and then we integrate each of this equation with x, and then we differentiate this equation with respect to z. I did number one and number two at the same time, and then after we got the answer, we just put delta z over delta x, and this is for the simulation. First, like usual, we define the function, and then we put the equation here, and then we solve this equation, and this pretty is to arrange the equation. Okay, if I run this, I will have the same answer here. Okay, if I run this, I also will have the same answer here. That's all for me. Thank you.
Assalamualaikum, my name is Muhammad Syami bin Muhammad Zainuddin. My matrix number is BEE20303. And today I will be presenting for the simulation part for the question 3A. So first step, we need to calculate all of the, we need to type in all of this command, which is the system xyz, and the function is exponent 2 power of negative 2 multiplied by z plus y, and sine y multiplied by z power of 2, and cos y multiplied by z multiplied by x, and the variance is xyz. So the last one, you need to calculate the divergence, so we need to type in the divergence curve, and after that we just run the simulation and we will get the answer is 0. Okay, for the question 3b, we need to type all the system xyz as before, but this time we insert the field 3 multiplied by x power of 2 and y power of 2 and 0, and the variance is xyz, and we need to calculate the divergence, the work done, the curve, field, variance, and the field is 3 multiplied by x power of 2, and the a for the initial f, 0 and negative pi, and after that we just enter. So we will have the answer, which is the answer is equal to a equal to negative. So for the question 3c, we can solve it in MATLAB by using simulation. So we have to solve it by using manual calculation. So we just have for the D divergence, we have to evaluate the set h z x squared plus zy squared x dy, and then we need to differentiate it. Also 1 plus x squared over z squared plus y squared over z squared dx dy, and then after we solve it, we will get the answer is set 2 dx dy. And after that, we need to evaluate the 2y squared plus 4z squared ds, and then we have to differentiate, so we will get set 2 in bracket 2y squared plus 4x squared plus 4y squared dx dy. And after we solve it, we will get the answer set 2 4x squared plus 6y squared dx dy. And after that, in polar, x is r cos theta and y is r sin theta, so the value for the r is 0, less or equal to r, or less or equal to 3. So we have to evaluate the answer that we will get before, which is set 2 for r cube cos squared theta plus 6r cube sin squared theta. And after we solve it, we will get the answer is 405 set 2 pi over 8. Thank you.
السلام عليكم ورحمة الله. I'm Omar Adel Hassan Dumaini. My matric number is AA2084, and I'm going to present part 4. So first, the difference, Gauss's theorem, which say a surface integral of a vector field where the surface is simple closed surface. That's where we use Gauss's theorem, which also called as divergence theorem, which is the double integral for v factor f multiplied with n dc for the surface S. And Stokes theorem says where Gauss's theorem is for finding the flux, and Stokes theorem is to finding the work, which is done by moving a particle along its enclosed curve. So Gauss's theorem, Stokes theorem is for surfaces, not a plane, where the surface is curved. Now for question B, the function here, so we first will do the divergence by doing the differentiation for every part with respect to its part, like B, the differentiation of B, where B is equal to Y with respect to X, and differentiation of Q with respect to Y, and differentiation of R with respect to Z. We'll get X plus 1. Then we do the sketch, the graph, as well we do it in the program, and we get it like this. So we have done the then using Gauss's theorem, which is triple integral for x plus 1 dv. Then we did the integral, we integrate, and the final answer was 32 pi over 3, which will be equal by doing the simulation on MATLAB. Oh my god, internet connection problems. Well, since I get internet connection problems, maybe I can only show the picture for it. We get the value is equal to 33.5. So, and for question S, first we sketch the graph, which by using MATLAB we get the same graph here, and then we use the manual calculation using Stokes theorem. So we find the work done by the vertical by doing the curl, where the curl is equal to del across F. We do the crossing, and we get the final answer is equal to Zi plus Yk. So then we compare, and we know that the surface is equal to x plus y plus z. So we find n, the vector field, and so we do the integral for s. So the double integral for r of r for zi plus yk multiply with the n. So therefore we get the final answer equal to 1/3. And the sketch or the calculation, since my internet connection is very low, I couldn't open MATLAB. So this is for question SI, and for SII we will show it again. Thank you very much for listening.